No.
Very good morning. See, I'm starting the session. Listen. So in the previous session, we have seen how to create the table using constraints. So we have used all these 6 constraints. Now in today's session, we want to create the tables by using constraint names. Listen carefully here. So to create the table, we must follow this syntax. Create table, table name. After that, we are giving field name, data type, constraint type. This you know. In today's session, we create the tables by using constraint names also. So in the previous session, we created the table by using field name, data type, and constraint type only. Field name, data type, and constraint type only we used. In today's session, we create the tables by using constraint names. So today I finish this constraints topic. Okay, listen. So topic name is naming constraints. Naming constraints. So we can give names to the constraints. We can give names to the constraints in SQL. So this is concept we are calling as naming constraints. We can give names to the constraints. If we don't give the name, implicitly Oracle gives constraint name by prefixing it by prefixing 6-digit random number with 6-digit random number 6-digit random number with sys underscore c. So Oracle gives constraint name by prefixing 6-digit random number with sys underscore c. For example, sys underscore c. Okay, 67345 like this. So like this, it gives the constraint name. So if we don't give constraint name, implicitly Oracle gives constraint name by prefixing 6-digit random number with sys underscore c. So when these names are useful, so these names are useful to disable the constraints, enable the constraints, and drop the constraints, Listen carefully here. See, try to understand, listen. For example, there is a table is there. table name is student. Student ID, student name, and student address we are maintaining. So in this, we are setting this record as the primary key. Okay, SID is the primary key now. So 1001, okay, student name and student city we are entering. For example, there is one student is there. We know his name and we know his city name, but college didn't assign student ID to him. Temporarily, I want to allow that record. Temporarily, I want to allow null value in the SID column. For example, student name is Sai, is from Mumbai. So college didn't assign student ID. So temporarily, we want to accept this record now. That is our requirement. Okay. So to accept this null value temporarily, we have to disable this primary key now. What is our requirement now? Generally, primary key means what? That does not accept the null value. But for this student ID not assigned, temporarily we want to accept this null value. No, that is our requirement. So what we have to do? We have to disable this primary key. To disable this primary key, disable means temporarily it will not work. Temporarily primary key will not work. So to disable this primary key, name is required. So that's why we use the names. Okay. So names plays key role when we are trying to disable the constraint. So now we are disabling. For disabling, generally we write like this: alter table name. Okay, disable constraint name we write. Okay, disable constraint. For example, if constraint name is C1, so C1 will be disabled. So this is the way of disabling. Here, what is C1 here? C1 is the constraint name. So here, by using constraint name only, we are disabling. Okay. Okay. Now, as of now, we are disabling primary key means it allows the null value. Later, they assigned student ID to him. So we are assigning, we are inserting that value. Okay. Now I want to enable the primary key. So to enable the primary key, again we write like this: alter table name, enable constraint name. So like this, to disable the constraint, to enable the constraint, we use this constraint name. Here C1 is constraint name. So this you learn in the alter command. Don't bother about it. My intention is when names are useful, I'm telling. Okay. So when names are useful, I'm telling this one. So when we are disabling the constraint or enabling the constraint or dropping the constraint, dropping means permanently we are dropping. Disable means temporarily we are disabling. Okay. Dropping means permanently we are dropping. Now primary key will not work. Permanently primary key will not work. So for disabling constraint, for enabling constraint, for dropping constraint, we use this constraint name. So without constraint name, you cannot disable, enable, or drop. So for this purpose, we have to give names to the constraints. Okay. So we can give names to the constraints. If we don't give names, implicitly Oracle gives constraint names by prefixing 6-digit random number with sys_c. This is implicitly defined constraint name. If we want to define the name, we can define by following identifier rules. We can give any valid name. Okay, and these names are useful to disable the constraints, enable the constraints, and drop the constraints. So in these cases, names are useful. So the convention is when we are creating the constraints, it's better to give the names. So now observe here, see one example. So example. We want to create one table. Okay, table name is student 5. In this SID, yesterday we created same table, but names we are giving. Yesterday we didn't give names. Now we are giving names. SID, S name, marks of subject 1. Okay. Now you tell me SID which type? Okay. SID which type? Number type. Okay. We want to set primary key. And for this, we want to give one constraint name. Generally, in the real time, how they give is they give like this. Okay, if they want to give primary key, pk underscore that table name, like this, they will give. So in the real time, if you want to apply the primary key, so pk underscore that table name, because constraint name must be unique in the schema. Okay, so like this, they may give. Okay, if you want to apply check, just simply you can write C underscore. Okay, if you want to apply R underscore like this, we can give the names. But I'm not giving those names. I'm not following standards. Just I'm giving name as X. X is the constraint name. For primary key constraint, what is the constraint name we are giving? X. X is the constraint name. Next, second field is S name. Which data type? Varchar 2 data type. We want to apply not null. We want to apply not null here, and I'm giving constraint name as Y. Okay, next M1. Which type? Number type. Okay, we are applying check constraint here. Check constraint we are applying. So for this constraint, we are giving constraint name as Z. Constraint name is Z. That's it. This is our requirement. Okay, now just observe this syntax now. To give the constraint name, we have to use constraint keyword. Observe this syntax. Now we write create query. Just observe this syntax. So create table, table name, field name, data type, constraint, constraint name, constraint type. Remember this. Field name, data type, constraint, constraint name, constraint type. Okay. So observe here. We want to create student 5 table. So right here, create table. What's the table name? Student 5. So student 5 is a table name. What is the first field here? SID. Which data type? Number data type. We want to set primary key and we want to give constraint name as X. To give constraint name, which keyword we have to use? Constraint. Constraint, give the constraint name. I'm giving constraint name as X here. Okay. So which constraint type we are applying? Primary key. So now we are giving constraint name. Observe here. Next, S name. Which data type? Varchar 2 data type. We want to give constraint name here. So constraint name is Y. We want to apply not null. Not null. Next, third field is what? M1. Which type? Number type. Size we are giving as 3. We want to apply check constraint here. So constraint Z. Constraint Z. Apply check constraint. Check M1 value must be greater than or equals to 0. And M1 value must be less than or equals to 100. So here we are creating the table with constraints with constraint names. Here X is the constraint name, Y is the constraint name, Z is the constraint name. To give the constraint names, we have to use one keyword, constraint keyword we have to use. Now complete table structure we are following now. So this is a way of creating the table. Now observe here. I'm opening SQL Plus. Okay. For our batch, username is Oracle 9 AM. Password is Naresh 18. Okay. So observe. See here. We are writing this create query. This create query we are writing. Okay. What it is telling? Table is created. SID is the field name. Number is the data type. Constraint keyword. X is the constraint name. Primary key is the constraint type. Okay. So field name, data type, constraint. Why is the constraint name? Not null is the constraint type. Okay, table is created. Now observe here. I am trying to insert the records into this table. What's the table name? Student 5. So we are inserting the records. Insert into student 5 values. I'm giving values as 1001. Okay, A 45 I'm giving. Does it accept this record? No. Does it accept this record? Yes, this record will be accepted. Okay, it is accepting the record. Now observe carefully. I am trying to insert one more record with same student ID. Okay, now does it accept this record? No. Why? Primary key does not accept the duplicate values. So just observe the error here. Observe the error. See here what it is telling. Unique constraint violated. Okay, so here what is this Oracle 9 a.m. here? This Oracle 9 a.m. C # Oracle 9 a.m. is what? Schema means user. Okay, what is XC here? Constraint name. Yesterday it was displayed sys underscore C, some number it displayed. Yesterday it displayed sys underscore C, some number displayed. Now what it is displaying? X it is displaying. What is X here? Constraint name. Okay, so if we give the constraint name, again Oracle will not give the name. If we don't give, at that time Oracle gives one random number by prefixing it with sys underscore C. Okay, that's it. So like this we can give names to the constraints. For example, one more record I'm inserting. I'm giving 1002 here, and marks value I'm giving as 455. Okay, now does it accept this record? Why? Check constraint. Check constraint will be violated. Now observe the error here. See what is the error it is giving. See, check constraint violated. Okay, here C # Oracle 9 a.m. schema. Z is what? Constraint name. Okay, so this is the way of giving names to the constraints. Okay, how to use these names, how to disable the constraint, how to enable the constraint, drop the constraint, that we discuss in the alter command. Okay, so now you know how to give the names. Now see, today we are giving names, tomorrow we may forget the names, or after 1 month we may forget the names. If we want to see the constraints list, okay, there is one system table is there. The table name is what? User constraints. All tables information will be stored in the user tables. All views information will be stored in the user views. All indexes information will be stored in the user indexes. All constraints information will be stored in the user constraints. Very, very simple. Remembering is easy. So this user constraints is one system table. It maintains constraints information. Okay, like constraint name, for which table that constraint is available, what is that constraint type. Okay, like that we can see. So it maintains constraints information. It maintains constraint information. So how to see? Observe. We don't know who created this user constraints table. Oracle developer. We don't know. We don't know what are the columns are there. If you want to see the table structure, what we have tried? Describe user constraints we write. Okay, so describe user constraints we are writing. Now what it will display? It will display the structure of user constraints table. So in the user constraints table, these many columns are there. Observe. So in this, important are constraint name, constraint type, table name. Okay, constraint name, constraint type, table name. Observe here, constraint underscore name is the column name. Constraint underscore type, table underscore name, these are the column names. If you want to see the list, you can write like this. Select constraint name. Select constraint underscore name, comma, constraint underscore type, comma, table underscore name. From which table we are retrieving? From which table we are retrieving? From user constraints. So select, this is the column list. Just this is the column list. From which table we are retrieving? User constraints. Select, we are giving column list from table name. Okay, so if you write like this, it will display all constraints list. Observe here. Sorry. I'm copying this query. See. So I'm setting line size here. So in one line, by default, it can display 30 characters maybe. Okay, so I want to increase the line size here. So I'm setting line size as 2000, means in one line, 2000 characters it can display. Okay, observe now what it is displaying. Yesterday we created some tables with constraints. For them, it has given some predefined names. Sys underscore C is there, means this is name given by the Oracle. Today we have given three names. What are those? X, Y, Z. Observe, sorry. Okay. Observe here. Here sys underscore C. Some random number is there. 6-digit random number is there. So these are the constraint names given by the Oracle. Yesterday we didn't give any constraint names. So it has given these constraint names. But today we have given constraint names X, Y, Z. These are. Okay. What are those constraint types here? That is showing here. Okay. C means check. Okay. P means primary key. U means unique. Okay. R means references. Okay. Yesterday in the student 2 table, we were using course IDs, references, foreign key. In the employee table, we were using department numbers, references, foreign key. Okay. C means check constraint. R means references. U means unique. For not null also, it will display C only. For not null also, for not null Y. Y. For not null also, it will display C only, check. Okay. So just now we created student 5 table. For the student 5 table, this is the primary key. Primary key name is X. Okay. This is not null. Not null name is Y. This is check constraint. Check constraint name is Z. That's it. Like this, we can see the constraints information by using this user constraints table. So tomorrow you want to disable the constraint, name is required. If you forget the name, you can see name like this. In which table? Okay, in which table we can see and which constraint name we can see here. Okay, that's it. This is about naming constraints. Next, listen carefully. We can apply constraints at 2 levels. We can apply constraints at 2 levels. One is at column level. Second one is at table level. One is column level and another one is table level. So all 6 constraints can be applied at column level. All 6 constraints, primary key, unique, not null, check, default, references, all 6 constraints can be applied at column level. So all 6 constraints can be applied at column level. But whereas for table level, in table level, only 4 constraints can be applied at table level. Only 4 constraints can be applied at table level. So what is this table level? What is this column level, sir? If constraint defined in field definition, if constraint is defined in field definition, field definition means what? Field definition means what? Field name, data type, constraint, constraint name, constraint type. This one is called one field definition. Field name, data type, constraint, constraint name, constraint type. This is called one field definition. In the field definition, if you specify the constraint here, this is what? Column level. So till now we applied constraints at column level only. Table level we didn't use. So only 4 constraints can be applied at table level. Okay. So what are those 4 constraints? Those are primary key we can apply at table level. Unique also we can apply at table level. Okay. Check also we can apply at table level, and references also we can apply at table level. Okay. Remaining which we cannot apply at table level, not null and default. Not null and default cannot be applied at table level. So table level means what, sir? After defining all fields, if we define the constraints, okay, these are called table level constraints. These are called table level constraints. After defining all fields, if we define the constraints, these are called table level constraints. So when we are defining column, in the column itself, if we define the constraint, that is called column level. If constraint is defined in field, this sentence is not over. In field definition, if constraint is defined in field definition, then it is called column level. Column level constraint. If constraint is defined in field definition, then it is called column level constraint. After defining all fields, if we define the constraints, then these are called table level constraints. Okay. Observe here. For example, we are defining one table. Okay. My requirement is I want to create one table here. Student 6 table. Fields are SID, SName, and marks of subject 1. Okay. So as for SID, which data type? Number data type. We want to apply primary key at table level here. So we want to apply primary key, and this constraint name I want to give as C1. C1 is a constraint. Next, S name field. Which type? Varchar 2 type. Varchar 2 type. We want to apply not null constraint. Same example, previous example only, but we want to apply table level. Not null, C2. Okay. Next, third field is M1. Which type? Number type. Size is 3. Check constraint we want to apply. So constraint name we are giving as C3. Okay. So can we apply not null at table level? No. We have to apply this at column level. Okay. So we can apply primary key and check at column level, but now we want to apply at table level now. And this check also we want to apply at table level. Okay. Now you tell me, here we are creating one table, student 5. and we are defining three constraints: primary key, not null, check. Okay, are they table level constraints or column level constraints? Column level constraint. Field definition only we define the constraint. That is column level. All six we can apply. In the previous session we have seen all those examples are column level constraints only. Now see how can we apply table level. Observe. So what is the table name? Observe here. Student 6. Three fields we want: SID, SNAME, M1. Okay. So right here, create table. Table name is student 6. Okay. First field is SID. Which data type? Number data type. Okay, but we don't want to apply the constraint here. Okay, table level we want to apply. Next, SNAME. Which type? Varchar 2 type. Okay, we want to apply not null. Can we apply not null constraint at table level? No, that's why we are applying at column level only. Constraint name I am giving as C2. C2 is the constraint name. Okay, not null. Not null, we are applying. So this is applying column level constraint. Next, M1. M1 which type? Number type 3. Number type, we want to apply check constraint, but we want to apply table level. So table level means what? First we define all constraints. After defining all constraints, first we define all fields, all columns. First we define all columns. After defining all fields, if we define the constraints, those are called table level constraints. Here all columns we defined. After defining all columns, now we are defining the constraints. So observe here, constraint. I'm giving constraint name as C1. Constraint C1. Okay. So which constraint we want to apply? Primary key. That we have to tell. Primary key. To which field we want to apply? SID field. That's it. This is called table level constraint. Are we defining this constraint in the field definition? No. Here field definition is there, but for this field we are applying constraint after defining all fields. So this is called a table level constraint. So when you are referring the books or websites, if author is defining primary key like this, don't get confused. If author is defining like this means you can understand that table level constraint. If author is defining constraint here, you can understand like column level constraint. Okay, so constraint C1, primary key of SID. Next, one more constraint we want to apply, check constraint. What we have tried here? Constraint name. Which constraint we want to apply? Check constraint. To which column? M1. M1 value must be greater than or equals to 0, and M1 value must be less than or equals to 100. Bracket close, semicolon. That's it. So sorry, C3. C3. Okay. So now, after here we are defining three fields. After defining three fields, here we are defining the constraints. This one is called table level constraint. After defining all fields, we are defining the constraints. Okay. Now, is it creating this table or not? Just observe here. At table level, we are defining constraints, two constraints, and one constraint we are applying at column level. Okay, is it creating the table or not? Just observe. What it is telling, observe here. Table created. So with this, you can understand that after defining all fields also, we can define the constraints. Here we are defining the constraint. So is it working or not? I want to check. So insert into, what's the table name? Student 6 values. First record we are giving as 1A40. Okay. Now does it accept this record? Yes. Once again we are running 1B60 I am giving. Does it accept this record? No, because student ID is the primary key. Primary key does not accept duplicate value. Observe here. So same, it is working. Primary key is working now. Unique constraint violated. What is the constraint name? C1. So here, are we applied at table level or column level? Are we applied primary key at table level or column level? Table level. Are we applied check constraint at table level or column level? Table level. Are we applied this not null at table level or column level? Column level. Not null, we cannot apply at table level. That's it. This is about table level and column level. Last one example I want to give, because how to set foreign key at table level you have to know. If you want to apply unique here, instead of writing primary key, just simply write unique of SID. Now student ID is unique now. That's it. This is the way of using unique. Now you know how to apply unique, how to apply primary key, and how to apply check at table level. One more you have to know, foreign key. Not null we cannot set at table level. Default we cannot set at table level. Remaining 4 are there. In the 4, how to set primary key at table level you know, how to set check constraint at table level you know, how to apply unique also you know. You have to know about references now. So same example I'm taking. Yesterday we created one table, course table we created. I'm taking table name as course 1. So here course ID, course name we want to maintain. So 10 is the code for Java, 20 is the code for Python, and 30 is the code for C#. So yesterday we created this table. Now again, once again we want to create, but this course ID I want to apply as the primary key at table level. Next, one more table is there. Okay, student 7 table we are creating. Okay, here student ID, student name, and course ID we want to maintain. Okay, here we want to apply this course ID as the foreign key at the table level we want to apply. Okay, so if we apply this as the foreign key, what is the benefit we will get now? If we enter 20, it accepts that value. If we enter 30, it accepts that value. If we enter other than 10, 20, 30, it gives error. I'm giving 45, it gives error. This is invalid data. Here it raises the error if you apply the foreign key. Okay, how to apply this foreign key at table level we have to learn. So we want to create this first table, course table we want to create. Observe, course ID, course name we want. What we have tried? Create table. What's the table name? Course 1. Course 1. First we are creating course table, because we want to set foreign key means first we have to create course table. Okay, so course 1, course ID, which data type? Number data type. What is the precision? 2. Course name, which type? Varchar 2 type. I'm giving size as 10. Okay, so now all field definitions are over. After defining all fields, we are defining the constraint names here. So constraint name I'm giving as A. Constraint name is A. Constraint name is A. Okay, constraint type I'm giving as primary key. Primary key, to which field we want to apply primary key? CID. Okay, are we applying primary key at table level or column level? Table level. Table level means after defining all fields, we define the constraint. Okay, so now is it creating this table or not? Just observe. See here. So what it is telling? Observe here. Table created. Okay, now we want to create another table. Create table name. Okay, next table is student 7. Create table name is student 7. First field is student ID, number type. Second field is S name, Varchar 2 type. Okay, next third field is course ID, number type 2. After defining all fields, now we want to define course ID as the foreign key at table level. Okay, at column level, if you want to apply, how you are writing? Constraint name. What we have tried here? References. Which tables which column data we want to accept here? Which tables, which columns data we want to accept here? Course 1 tables, course ID. Okay, so course 1 tables, course ID data we want to accept here. So what we are writing here? Course 1's course ID data. Okay, like this you can apply foreign key. This is it table level or column level? Is it table level or column? In the field definition only we are defining. Okay, this is the field definition. In the field definition only we are defining. In the field definition, if we define, that is column level. But the same thing at a table level we want to define. So after defining all fields, right here, constraint, give the constraint name. I'm giving constraint name as B. So constraint name B. Okay, then to which field you want to set the foreign key, you have to tell. So previously for column level we are writing like this: constraint B references course 1 tables course ID. Okay, so course 1 tables course ID values you want to accept. Okay, in which column it is not understanding? Observe here. If you write like this, constraint B, constraint name is B, references course 1 tables course ID values. This course 1 tables course ID values, in which column you want to accept? It is not understanding. That one we have to tell. So which field you want to set as the foreign key, you have to tell here. So that's why we write like this: foreign key. Foreign key. To which field you want to set foreign key? SID field. That's it. Then remaining, references course 1 tables course ID values. So this is called, CID. CID. Okay, so CID column we are applying as the foreign key. Okay, so this is called applying foreign key at table level. So to apply the foreign key at table level, we have to write like this: constraint name, foreign key. To which field you want to set foreign key? CID column. Okay, so in the CID column, which tables data you want to accept? Course 1 tables course ID columns data we want to accept. So references course 1 tables course ID. Like this way. Okay, so this one you already know. Just this one we are writing extra, because if this one is not there, that cannot understand writing. That's it. Okay, so this is applying foreign key at table level. When you are referring the books or websites, if author is writing foreign key, some column name references, don't get confused. He is applying foreign key at table level. Okay, so this is about constraints. Constraints topic is over. So in today's session, what we discussed, once again I'm giving overview. Observe. So first we started with naming constraints. So we can give names to the constraints. If we don't give the names, Oracle will give the name. Okay, so if we want to give the name, we write constraint name, constraint type, like this. And all constraints information stored in one table. What is the table name? User constraints, user underscore constraints. Okay, and we can apply these constraints at two levels. One is column level, another one is table level. Okay, for example, here we are applying primary key constraint, check constraint, not null constraint. Is it table level or column level? Column level. Why we are calling this as column level? In the field definition we are defining. In the field definition we are defining means column level. Okay, table level means after defining all fields we define them. So here we are defining all fields. After defining all fields, all constraints we are defining at one place. These are called table level constraints. Okay, so here we are applying primary key at table level, check at table level, not null we cannot apply at table level. Okay, and if you want to apply unique, instead of writing primary key, just write unique of column name. If you want to apply foreign key at table level, write constraint name, write foreign key here. To which field you want to apply foreign key, that column name we have to write. And in this CID column, Okay, which values we want to accept, we have to tell. So use references keyword, course one tables, course ID values will be accepted in this CID column. That's it. This is the way of creating the foreign key. Observe here, I'm creating this. Table is creating or not? See, so here we are applying it table level. Here we are applying foreign key at table level. Table is created. Is it working or not? I want to check. So first insert records in course one, then insert records in student 7. Observe here, insert into course one. In the course one table, we are inserting the values. So 10 course Java name I am giving, and 20 course Python I am giving. 20 course Python. Okay, so two records I inserted. I'm saving the data. Now I want to insert the records into the student 7 table. So to insert the records into student 7 table, right? Insert into student 7 values. Observe here, I'm giving student ID 1, name A. Okay, 20 course I'm giving. 20 values available, so it is accepting. Okay, I'm giving course ID as 120. Is 120 course is there? No, 120 course is not there. Now it raises the error. Observe here. Okay, sorry. Actually, precision is 2 there. Only 2 digits value only I'm giving. I'm giving 12. Is there any 12 code? No. Okay, what is the error it is giving? Observe here. Integrity constraint violated. Okay. See, B is the constraint name. So our foreign key is working perfectly. So this is about table key. Constraints topic is over. Is it clear about constraints? Please confirm. Okay, did you get some idea about table level and column level? Okay, now see, we are learning SQL. In the SQL stands for structured query language. Okay, why we are using it? It is used to write the queries. Why we are writing queries? To communicate with database. So to communicate with the database, we are writing these queries. So in the database, okay, we want to create the table, or we want to insert the records, or we want to delete the records. So to deal with the database, we are writing queries. So this SQL is providing how many sub languages? 5 sub languages. What are those? DDL, DRL, DCL, TCL, okay, and DML. Okay, so these are the 5 sub languages. So among these, we are discussing about DDL commands only. So what are the DDL commands are available? Create, alter, drop, truncate, rename, okay, flashback, and purge. So total 7 commands are there. These 7 commands are comes under the DDL commands. Now you know very clearly about the create command. Creating tables, you know now. Okay, how to create the table, you know now. Complete syntax, you know. Every point regarding creating table, you know now. Observe. So create table, table name, field name, data type, constraint, constraint name, constraint type. Every point regarding, you know, everything you know. Now, listen. Next second command is what? Alter command. Now I want to talk about alter command. Listen. What is the general meaning of alter? Alter means what? Change or modify. Okay, alter means what? Change. Okay, altering the building means already building is existed. We are making some changes. Okay, bike alteration. Okay, building alteration. Okay, means already building is existed. We are making some changes. Bike is already existed. We are making some changes. That is the meaning. So in the existing one, if we want to make the changes, we use the term alter, alteration, altering. Okay. See, alter means change. So when we use it, sir, listen. For example, here one table is there. Student table is there. In this, student information is there, like student ID, student name, and city, student city. Now, how many columns are there? 3 columns are there. This is existing table now. In the future, this is existing table. Already table is existed. I want to add one column now. I want to add one column. Okay, gender column I want to add. Is there any gender column now? No. We want to add gender column now. So is it existing table or not? Yes, this is the existing table. To the existing table, we are adding one more column, gender, one more column, mobile number. Like this, to add the columns to the existing table, we have to use which command? Alter command. So we are changing the structure of the table here. So to change the structure of table, we are using this alter command. Here we are adding 2 columns. And tomorrow, we don't want these 2 columns. We want to drop them. We can drop. So we can add the columns. We can drop the columns. And this is the existing table. In this student ID, for student ID, no primary key is there. I want to add the constraint now. So to the existing table, we want to add the constraint. At that time also, which command we have to use? Alter command. So finally, alter means change. To change the structure of table, we are using alter command. Here already table is there. In these 3 columns are there. One more column we want to add, use alter command. No, we want to drop this column. Okay, use alter command. Okay. If you want to add the constraint, use alter command. Like this, to change the structure of table, we use this alter command. Alter command is used to change structure of existing table. So if you want to change structure of existing table, we can use this alter command. Alter command is used to change structure of existing table. So using this command, what we can do, see here. So using alter command, what we can do, I'm writing the list here. Using alter command, we can, okay, what we can do, we can add the columns. We can add the columns. All possibilities I'm writing, observe. So table is, existing table is there. We want to add some more columns, use alter command. Okay, next, we can rename the columns. So if you want to modify the column names, we can use it. Okay, next, we can drop the columns. We can drop the columns. Okay, next, we can add the constraints. We can add the constraints. Next, we can disable the constraints. We can disable the constraints. So we can enable the constraints. We can enable the constraints. Okay, next, we can rename the constraints. We can rename the constraints, and we can drop the constraints. We can drop the constraints, and last, we can modify the field sizes. We can modify the field sizes, and we can modify the data types. So all these are the possibilities with alter command. So total 10 purposes are there. For these 10 purposes, we are using alter command. Using alter command, we can add the columns, we can rename the columns, we can drop the columns, we can add the constraints, we can disable the constraints, we can enable the constraints, rename the constraints, drop the constraints, modify the field sizes, and modify the data types. For these 10 purposes, We can use alter command, all these. Okay, so using this alter command, what we are doing, we are changing structure of the table. That's it. Okay, so for this we have to follow one syntax. That syntax is syntax to use alter command. So syntax of alter command syntax, very easy. Observe, for every alter command we write like this: alter table name. This is common. Based on our requirement, we use some keyword here. Okay, alter table name. This is common for every alter command. If you want to change the structure of table, write alter table name. But based on our requirement, here keyword will be changed. If our requirement is adding column, we write add keyword here. If our requirement is adding column, we use which keyword here? Add keyword. Okay, then alter table name. If our requirement is dropping one column, we write drop column here. Drop column here. If our requirement is renaming the column, alter table name. Here we write rename column. Rename column keyword we have to use. Based on our requirement, we use the keyword here. Alter table name, add. Which columns you want to add, we have to tell. Alter table name. If you want to rename the column, write rename column here. Alter table name. If you want to drop the column, write drop column here. If you want to drop multiple columns, write drop here. Drop keyword we have to write. Okay, next, if you want to modify the field sizes, we have to write modify here. Modify the field sizes or data types, we write modify we write. If you want to add the constraint, we write add constraint keyword here. If you want to disable the constraint or rename the constraint, we write rename constraint here. If you want to disable the constraint, write disable constraint. If you want to enable the constraint, enabled one, we want to disabled one, again we want to enable, so write enable constraint here. Enable constraint we are writing. Okay, next, if you want to drop the constraint, use the keyword drop constraint. Okay, so like this we can use alter command. Okay, alter table name, add is for adding the columns. Rename column is for renaming the columns. Drop column is for dropping one column. Drop is for dropping multiple columns. Modify is for modifying the data type or field size. Add constraint, to add the constraint we use this keyword. Rename constraint, for renaming the constraint we use it. Disable constraint, for disabling the constraint we use it. So disabled one, again if you want to enable, use enable constraint, then write drop constraint. So according to our requirement, we use these keywords. So these keywords are optional. Based on our requirement, we use them. So specifying add is optional. Okay, rename column is optional. So to indicate optional, here I'm using square braces. So among these, first one is what? Add. Why we are using this add keyword, sir? Using add keyword, we can add the columns. Okay, so how can we add? Observe here, I'm writing the syntax here. Add, in the parenthesis, define the field definitions. Field definition means what? Field name, data type, constraint name, constraint type. I already told. Okay, so whenever I'm using the field definition term, understand like field name, data type, constraint name, constraint type. So field definitions we define here. That's it. For multiple fields, parentheses are required. For single field, parentheses are not required. Next, for renaming column. So rename column, give the old column name. Old column name we have to give to new column name we have to give. So this syntax we have to follow. So rename column is used to rename the columns. So add is by using add keyword, we can add the columns. Okay, by using rename column, okay, we can rename the columns. We can rename the columns. Okay, next third one is drop column. Drop column, which column you want to drop, that column name we have to tell. Okay, and next drop. Drop is used to drop multiple fields. So column list we have to specify here. Which columns you want to drop, that column list we have to specify. Next, modify. Modify, then define the field definition. That's it. Modify, new field definition we give. Modify. So which field, which data type, which field size, okay, that we give here. Constraint, constraint name, those also you can give. Field definition means field name, data type, constraint, constraint name, constraint type. So field definitions we can specify. Next, add constraint. After add constraint, what we have to write? Constraint name. Constraint name we have to specify. So rename constraint, give old name to new name. Give old name to new name. Next, disable constraint. Constraint name. Which constraint you want to disable, that constraint name we have to give here. Next, enable constraint. Constraint name. Constraint name we have to give. Next, drop constraint. Constraint name. Constraint name we have to give. So this syntax we have to follow. Okay, so this is the syntax we have to follow for altering the table. So with the keyword name, you can understand the purpose easily. Add purpose is what? Adding column. Rename column purpose is what? Renaming column. Drop column purpose is what? Dropping one column. Drop purpose is what? Dropping multiple columns. Modify purpose is what? Modifying data type or field size. Modifying data type or field size. Add constraint purpose is what? Adding constraint. Okay, so for adding constraint, add constraint, constraint name, constraint type also we have to specify. Constraint type. Constraint type also we have to specify. Add constraint, constraint name, constraint type. So rename constraint old name to new name. For renaming column, for renaming constraint name, rename constraint we use. Okay, for disabling the constraint, disable means temporarily it will not work. Disable constraint, constraint name. For enabling the constraint, enable constraint, constraint name. Okay, if you want to drop the constraint permanently, drop constraint, constraint name. So like this, we can use alter command. Just a minute. So this syntax we have to follow for altering the table. Okay. So did you understand the purpose of alter command? Okay. So now with one example, okay. So actually I need to cover alter command example, but it takes some time because 10 purposes are there. It takes some time. So that's why I'm stopping the session here. In the next session, I explain one example on alter command. Using one example, I cover all these 10 purposes. Okay, I'm stopping the session here. On Monday, we discuss example on alter command. Okay, thank you everyone. See you on Monday. Okay, so notes I'm uploading in the notes link. I'm not in the Google Classroom, so that's why I'm uploading temporarily. I'm uploading in this notes link. Okay, so after joining in the Google Classroom, I will upload in the Google Classroom. As of now, temporarily I'm uploading in the notes link. Please refer here. Okay, thank you everyone. See you on Monday. Okay, notes till yesterday I already shared. When you open this link here, every day I'm overwriting this file. Oracle 9 a.m. first file is there. Every day I'm overwriting this file. Till yesterday class notes is available. You can check there. So yesterday we discussed about constraints, setting foreign key. So till here notes is available. Today's notes I will upload.